Welcome geometry students to West Explains Best. Today we are doing 4.1 congruent figures. We're starting chapter 4. We're going to get into congruency and different triangles and stuff like that. But first we need to understand what is a congruent figure. A congruent figure, if we're looking here, these might be said to be congruent. But why? Because they have the same angles and same side lengths. Actually, I'm going to change this to angle measures because they have to have the same measure. Okay, so same angle measures and the same side lengths. There we go. So that's congruent figures. Now, here we have the figure KEYS, and we could say it's congruent to another shape. And let's call the next shape, I don't know, let's just keep it simple for now. I hate being this simple, but let's call it ABCD. Okay, so we have ABCD congruent to KEYS, but now we have to make sure that the letters are in the same order in terms of their respective angles. What do I mean by that? Well, if we look here, this angle K looks to be 90 degrees, and so does this angle S. We look over here, we see the two 90 degrees are up here now. So what I'm trying to say is, we can say ABCD is like this. That would be wrong. Why? Because K is the first letter listed here, and A is the first letter listed here. So because the K is 90 degrees, that would mean that this A needs to be 90 degrees. And you can see that it's clearly not. So we can't just label it however we want. We have to be very specific with our labeling. So we got to erase that. Instead, if we want to say it's congruent to ABCD, we have to start angle A in the same exact place. So let's say ABCD. We have to make sure that this angle K and this angle A are in the same place. Okay, how do we know this is in the same place as if we call this A as an angle K? Well, because it's directly beneath this next obtuse angle here. And you can see there's an obtuse angle there, and so we can call that B. So B and E both need to be the obtuse angles, and they are. Okay, so actually I'll make this like this light green color right here, and I'll highlight these B right here. Then we have C. Okay, so we'll highlight this in yellow. Yellow, you see it's an acute angle. So here's angle C, here's angle Y. Those need to be equal to each other, and they are, because they have to go in order here. Then we have angle D. We'll label it or designate it with light blue. This is one of the 90-degree angles. So we know that D and S need to be congruent. Okay, and we already determined that K and A are both 90 degrees, so they are in the same place also. So you have to go in order. If you want to say KEYS is congruent to ABCD, then they have to be listed in the same order with the same angle measures. Now the other part of it, we already talked about the angles, so we know that K is going to be congruent to A, Y is congruent to C, E is congruent to B, and S is congruent to D. We already established that. We could also say that the sides are going to be congruent also. So KE is this short side here. That needs to be congruent to AB. So we're going to go ahead and label that. So AB. Then we have YS. So YS is this longer side. So that's got to be congruent to DC. Then we have EY. I'm kind of strange order I'm going in. I was going down instead of to the right. This has got to be congruent to the long diagonal side, so that's BC. And then SK has got to be congruent, if you guys can predict, to this last one, 1, 2, 3, 4, 1, 2, 3, 4, so that's DA. Okay, now we could also say that KEYS, we could label it in a different way. So we could say SKEY. As long as we go in order, either clockwise or counterclockwise, we're fine. Okay, I chose to go just SKEY clockwise. So now I need to label my angles in the same color order. The angles need to match the angles listed here. So I couldn't call it CDAB because C and S are not equal. Instead, I must do the corresponding angles. So that's D, A, B, C. Therefore, all those angles match each other. Moving on to the next, that's actually kind of colorful. Really nice. Moving on, are these triangles congruent? Okay, now, we already said that they have to have the same angle measures and the same side lengths. Okay, so we're going to go here and we're going to see, do they have the same side lengths and do they have the same angle measures? Let's start with the sides. So here we have this side, ED, is going to be congruent to BA because of those little lines. Okay, so we got that. We're given that this is 6 and this is 6. So we have those matching. And then we have this is 4 and this is 4. So we have the sides are good. Okay, so side lengths, check. Now the angle measures. We have to check that. So here we have this angle matches this angle because it's given with the little arc line. We have B and D congruent, okay? But now we're missing the last angle. So can we write this as not congruent? No, because these are vertical angles. We can write these as congruent because they are vertical. So are these triangles congruent? Yes. We have the same angle measures. Angles, check. And then sides, check. Okay. Moving on. Color this in if you are following along in the guided notes. Third angles theorem. What is this about? Well, if we know B is congruent to E and A is congruent to D, then what do you think we know about the rest of this triangle? Well, since it's called the third angles theorem, we probably can say that angle C is going to be congruent to angle F. Angle C is congruent to angle F. Why does that work? Well, if we know that two angles, okay, so let's highlight this, light green. If we know that these two angles are the same, okay, this third angle needs to add up to 180 with the green angles. So if they both need to add up to 180, the same number, then they have to be the same measure. So that's why C and F have to be the same. So that's actually a pretty useful theorem that we'll use in example 2. So given all these things, and the givens are here, so LM, LO, that's this one. Okay, then we have MN, ON, MN, ON, those are congruent. Then we have angle O and angle M, that's here. And then lastly, we have MLN, this one, and OLN, that one. Okay, so we're given that. We need to prove that LMN and LON, those two triangles, are congruent. Well, first we should probably identify where are those two triangles. So I'm going to make this a little bit thinner, and I'm going to make one of these triangles a light purple. Let's do the LON. So LON is this triangle. Very important to highlight your triangle, see what you're working with. And then let's do, I guess let's go with this dark red color here for LMN. So LMN is this triangle. Okay, so we can see that we have two angles matching. Okay, we have two angles matching each, and we have two sides matching in each. So that's just kind of like my pre-thinking here. So let's get right into the statements at this time. So we have LM and is congruent to LO. That is given. Okay, that was given here. Oops, given. MN and ON, that was given. Okay, we can actually list this because we can list this for both of these. Okay, that applies to both. Okay, so we'll just say given and we'll move it down kind of like in the middle. So we see that both of those are given. LN is congruent to LN. Okay, where is LN? LN, I'm not talking about LN, I'm talking about LN. So LN is this orange line here. How do we know that is congruent to itself? This is the long-awaited reflexive property. Okay? It's the same line. LN is the same line as itself. Obviously, reflexive, like let's look in the mirror. But because it's part of both the purple triangle and the red triangle, we have to list it as congruent for us to know that we have another side. Okay? So this was another side that we've established as congruent. This was a side here. This was a side here. So guess what? We got our three sides taken care of. We have sides done. Okay? Now, let me change that to a green check mark. I like that better. Sides done. Now we just need to worry about the angles and see if all the angles are congruent. So now we are looking, okay, what's given? Well, we know that we have, let me go to this light purple. We have angle M congruent to angle O. Whoops. Congruent. And then we have angle MLN congruent to OLN. Okay. And that's given. We know that because it's given right here. Check. I'm going to check this one just because we already did it. Now, third angle's theorem is the reason, okay? What's the third angle here? If we know that two angles plus this third angle need to add up to 190, then we can figure out that this last angle here, this guy and this guy need to be congruent because the other two angles are also congruent. It's the third angle's theorem. So what can we call those two angles? We can call it angle ONL. Again, you write the vertex with the letter in the middle. And then that's congruent to, n's got to be in the middle again, but this time it's MNL, and that's the third angle's theorem. So now we have, guess what, three angles, and our last statement is LMN is congruent to LON. That's what we're trying to prove, okay? That's this statement here. And why is that the case? Because all angles and sides are congruent. And that's it. That was the first section. That's the introduction. It's going to be a lot more proofs in this one. Hope you enjoyed this video. Thank you so much for watching.